Here are the answers for the Day 2 study guide over chapters 3 and 4. The replacement set of each of the variables is given. So in the first equation, we're going to use real numbers as our replacement set. Giving the coordinates in the order specified in red type, name 3 roots of the sentence. So this is in red ink originally in the book. This is just telling us we want to give our answers in parentheses, giving the answer for x first, then the answer for y. One possible answer is 0, 10, because if x is 0, then y would have to be 10. Another answer is 1, 8. When you use 1 for x, 2 times 1 makes 2, and then this would have to be 8. Another possible answer is 2, 6. We could keep going, but we have to give 3 answers. Number 13 is very similar. We want to find solutions to this inequality problem, and we want to give our answers as ordered pairs, x, y. So let's follow the same strategy we did last time and choose values of x. For instance, what about when x is 0? 2 times 0 makes 0, and 0 take away what number makes an answer that's greater than or equal to 4. One possibility is -4. 0 take away -4 is 4, and that's greater than or equal to 4. We could use 0 again and pick another number for y that works. For instance, -5. This solves the inequality because 2 times 0 is 0 minus -5 equals 5, and that is greater than 4. At this point, you probably notice a pattern. Here's one more answer. We could find all kinds of answers that have 0 as the x-coordinate, but we could even use other numbers for x. Next step, we're asked to graph the equations. These go to the first power, so these are linear equations. They're going to make straight lines. When you have an equation in this format, where x and y are on the left and the constants on the right, that is called standard form. There are different ways to graph a line when it's in standard form. One way that works very well is called intercepts method. Find out where it touches the x-axis and where it touches the y-axis. When you use a 0 for x, y turns out to be 5, because 0 here plus 5 makes 5. There's a dot at 5 on the y-axis. That's called the y-intercept. Let's get the x-intercept. When you use 0 for y, x turns out to be 5. So there's a dot right here at 5, and our line goes downhill. Number 11 is also a linear equation. I know that because my exponents are 1s. Let's put this in standard form by adding the 8 to the right side. Then we can find the intercepts. When you use 0 for x, y turns out to be 8. When you use 0 for y, let's figure out what x is. We would have 6x plus 0 equals 8. Divide both sides by 6, and we get x equals 8 over 6. As a mixed number, this is 1 1/3. With these two ordered pairs, we can make our graph. 0, 8 is up here at 8 on the y-axis, and 1 1/3, 0 is right here at 1 1/3 on the x-axis. Then draw the line in going downhill. Number 17 is in standard form. We could use intercepts method again. When x is 0, y is -2. Because 2 times 0 makes 0, and then we would have minus 3y is equal to 6. Divide both sides by -3 to get y alone, and you get -2. Now let's get our x-intercept. What does x equal when y is 0? Well, x would have to be 3, because 2 times 3 minus 0 equals 6. Now we can graph. 0, -2 is located here at -2 on the y-axis. 3, 0 touches here at 3 on the x-axis. And draw the line going uphill. This is not the only way that these 3 problems could have been done. We could have solved for y, which is called making slope-intercept form. and we could have graphed it from that form. Next, plot each pair of points and draw a line through them. So let's make a grid and locate the dots. 1, 2, 1, 2, 3. 1, 2, 3, 4, 4, 5. So over 4, up 5. Here is our line. Now we're asked to determine the slope from this graph. So slope is rise over run. From this dot, you rise 2 units and you run 2 units. This makes 2 over 2, which reduces to 1. Now we're asked to check our answer using the slope formula. The slope formula is m equals y2 minus y1 over x2 minus x1. In our ordered pairs, this is x1 and y1. This one is x2 and y2. Let's fill our numbers in. 5 minus 3 over 4 minus 2. When you work this out, you also get 1. Next question, we're asked to graph this. So 1, 2, 1, 2, 3. Here's negative 2, comma 3. Here's negative 3, comma 3. Draw the line through. It is a horizontal line crossing the y-axis at a height of 3. We're asked for the slope of this. Well, it doesn't rise at all, so the slope is 0. Now we're asked to check that answer using the formula. So y2 is 3, y1 is 3. x2 is negative 3, x1 is negative 2. This makes 0 over negative 1, which reduces to 0. Number 13, through the given point, draw a line with the given slope. So we need a grid. Left 1, up 2. There's negative 1, comma 2. Now what does it mean m equals 1? That's telling us the slope is 1. Or if you think of that as a ratio, 1 over 1. That's rise, that number is run. So from this dot, we want to go up 1 unit, right 1 unit, and draw the uphill line through. Number 18, we're asked to draw the line. 1, 2, 3, 4, and up 1. Here's negative 4, comma 1. Our line has no slope. Well, what does it mean to have no slope? That's like saying that m is equal to 0, that it doesn't rise at all. So you draw a horizontal line through the dot. We'll cross the y-axis at the 1. Sorry about the little dip right there. This should be perfectly straight. Next one, do the points lie on a line? If so, give the slope. To lie on a line, there's a constant rate of change from one dot to the next. Let's find the rate of change. When this increases 1 unit, this increases 2 units. This changes by 1, this changes by 2. When that changes by 1, this changes by 2. Let's write change in y over change in x. The reason we do it like this is because change in y finds the rise. Change in x finds the run. So this is 2 over 1 equals 2. Because this was constant every time, the answer is yes. And our slope is 2. Next one, for each line, find A, the slope, and B, the y-intercept. So this is in standard form. If we want to find the slope and the y-intercept, it would help to put it in slope-intercept form. Slope-intercept was this pattern. The letter y is alone on the left. The x term is after the equals. The constant term's on the end. So let's fix this. It doesn't have the right format. Subtract 3x from both sides. We get negative 3x and then the positive 8. Then divide by the negative 4 to get y alone. We get negative 3x over negative 4 plus 8 over negative 4. And now let's reduce. Negative over negative makes positive 3/4 x, and positive divided by negative makes negative 2. Now that we have slope-intercept, there's our value of m. That's our slope. And there's our value for b. That's our y-intercept point. We're asked to draw the line. So let's make a grid. Find the y-intercept at -2, and then use the value of the slope to do rise over run. So let's put a few more marks on here. From our first dot, rise 3 and run 4. Draw the uphill line. Question A, draw a line passing through the given point with the given slope. And then question B, write the equation in standard form. So first thing, we're asked to draw the line. So we need a grid. 1, 2, 1, 2, 3. Here's 2, 3. Now this is our slope value. If you think of it as -1 over 1, then that's the rise and that's the run. But what does it mean for the rise to be a negative? It means you actually go down 1 unit and then over 1 unit. Here's the downhill line. Now we're asked to create an equation, and we want the equation to be in this format. Well, what information do we have to work with? We have a point and we have the slope. So let's use point-slope form. The formula for point-slope form is y minus y1 equals m times x minus x1. I realize this doesn't have the pattern that we're asked for, but this is how we're going to begin because point-slope form fits our given information, a point and a slope. For y1, fill in the 3. For m, fill in -1. For x1, fill in the 2. Now do the distributive property. -1 times x is -x. -1 times -2 is +2. Now that we have our equation started, we can change it to this format. Notice the x term is the very first thing. So the x is not in the right spot. Let's add x to both sides. We get x plus y minus 3 is equal to the 2. This is what we have right now. This is what we're trying to create. What's not in the right spot? It's the constant term, the 3. So let's add 3 to both sides. We get x plus y equals 5. Now we have standard form. The value of capital A is a 1. The value of capital B is a 1. The value of C is the 5. Next, find a linear equation whose graph has the given points and the equations in standard form. Here we have point 1 and point 2. From those 2 points, we can find the slope of the line using the slope formula. 7 take away 4 over 6 take away 3. This is 3 over 3, which reduces to 1. We have the slope, and we have a point that's on our line. So just like last time, we're going to use the point-slope form. Y minus 4 equals 1, and then x minus 3. This is not the right format because it wants standard form. So let's do the distributive property like we did before. 1 times x is x. 1 times -3 is -3. Then subtract the x to move it to the left side. Then move the constant 4 to the right side. Now we have standard form. The value of capital A is a -1. The value of B is a 1. The value of C is a 1. Those are all integers, and that's what it wants for A, B, and C. Number 19 is the same kind of question. So first find the slope. From -3 to +2, the y value has increased 5. From -3 to -1, the x value has increased by 2. or you can get the slope by subtracting the values. Now that we know the slope and we know a point, we can use point-slope form. Y minus the -3 equals 5/2, and then x minus -3. Let's fix the double negatives. They become plus signs. Now let's multiply everything by 2 to get rid of the fraction. We have 2y plus 6 equals 5 times x plus 3. Now do the distributive property. We have 2y plus 6 equals 5x plus 15. Now subtract the 5x. We have -5x plus 2y plus 6 equals 15. Now subtract the 6. We have -5x plus 2y is equal to 9. There's the standard form, all integers as our coefficients. Next, determine an equation of the line given the stated conditions. We want our line to have a y-intercept of 3. We want it to be parallel to the line that goes with this equation. Lines which are parallel have the same slope. So what's the slope of this? It's a 1. That's the slope. The 3 is the y-intercept. Because we know the slope in the y-intercept, the best form to use is slope-intercept form. The pattern for that is y equals mx plus b. So we have y equals 1x plus 3. Next, solve the system and say whether the equations are dependent, inconsistent, or independent. When we were studying this section, we didn't worry about these words so much, so you can ignore those terms here. What we're really asked is to solve the system. So we know that there are different ways to solve a system. There's substitution method and there's combination method. Either of them is fine. I'm going to choose combination method. In combination method, we want one of the variables to have opposite coefficients. Like, because this is positive 5x, we would want this to be negative 5x. Or if you look at the letter y instead, because this is negative 3y, we would want this to be positive 3y. Let's make the letter x's cancel. So in the top equation, multiply by -5. The top equation turns into negative 5x minus 5y equals -25. Then keep the second equation the same as it was to begin with. Now combine them together. This is why it's called combination method. Negative 5x combined with positive 5x cancels. Negative 5y and negative 3y is negative 8y. Negative 25 plus 17 is negative 8. Divide both sides by negative 8 and you get y equals 1. Okay, we're halfway done. We have the answer for y. Now let's get the answer for x. In the original equations, which one looks easier to substitute a 1 for y? I think probably this first one, right? Put a 1 right there. So we have x plus 1 equals 5. So what's x? X is 4. It's common to write your answer as an ordered pair. 4, 1. Always put the x coordinate before the y coordinate. Here's our next system. We can use substitution or combination. I'm going to choose combination because I noticed that the y terms already will cancel each other away when you combine. X plus x is 2x. Positive y and negative y cancel. And 10 plus 8 is 18. Divide both sides by 2 and you get x equals 9. You're already halfway done. Then substitute 9 into that equation. 9 plus what equals 10? And then you can see that y has to be 1. So the answer is 9, 1. Next one, we could use substitution or combination. Either works. Since I've done combination twice, I'm going to choose substitution this time, just so you can see how it's done. Take one of the equations and rearrange it so that one of the letters is alone. I think it's pretty easy to get the letter Q alone, because what you need to do is subtract the 2p. You'd get 5 minus 2p. Take that binomial and substitute it for the letter Q in the other equation. This is why it's called substitution method. So the second equation becomes 4p plus 2, and then in parentheses, substitute 5 minus 2p, and then equals 6. Here's the second equation. Here's what it looks like after substituting. We're replacing the letter Q with this binomial. Now solve this. Let's do the distributive property. 2 times 5 makes positive 10. 2 times negative 2p makes negative 4p. That equals 6. Now combine like terms. 4p minus 4p cancels. We're left with 10 equals 6. This has no variables left, and it's a false statement. So this tells us there's no solution. Next one, graph the solution set of the system or of the open sentence. This one's just a single open sentence. It doesn't have two statements to be a system. So let's make a grid. If this was y equals x, then that's a really famous diagonal line with slope of 1. So it goes through the origin, and the slope is up 1 over 1, up 1 over 1. Right? It's this diagonal pattern of dots. Now before we draw the line, pay attention to the arrow. There's not an equals bar. So this is a dashed boundary line. Now decide where to shade. That symbol is the is greater than. So you want to be above a boundary when it talks about being greater than something. Number 9, same thing. First, let's rearrange it so the letter y is alone. You would have to subtract the 5x. The reason you do that is to make slope-intercept form. It helps you make the boundary line. The y-intercept is 0 again, but this time the slope is negative 5. Down 5 and over 1. Pay attention to that arrow before you draw your boundary. There's not an equals bar. So is it solid or dashed? Draw a dashed. This is a is greater than, so you want to be above the boundary when you shade. Next one. Again, this is a single inequality. Let's solve it for y. We would have to add the 4x to the other side. Now we have slope-intercept form. The y-intercept is at negative 2. And in front of x, the slope is 4. So from the dot, you go up 4 units and over 1 unit. Now look at that arrow. You see the extra line on it? That is a solid boundary. This is a is less than, so you want to be under the boundary. Being less than something means being under it. Number 22 is a system because there are two statements put together. So we're going to get two boundary lines when we do this. Let's do this first one. This is like having y equals 1x plus 0. So the y-intercept is 0, and the slope is up 1 over 1, up 1 over 1, and so on. This diagonal pattern of dots. Now look at that arrow. You see the line there? Solid. See the less than? We're going to be under that boundary. Now let's remember that we're going to be under it. We're going to do the shading later. Okay, now go to this next one. We're going to graph this now. If this simply said y equals 0, that is a horizontal line crossing 0. Because it's got the little bar, we're going to draw it as solid. So horizontal line right on top of the x-axis. Now the greater than means above. We want to be above this horizontal red line. Do you remember where we were going to shade for the first boundary? We were going to be under it. So under the purple one and above the red one. That's this region of space. Number 31. Same idea, two boundary lines with some shading. Unfortunately, these are not in slope-intercept form. So that's our first step. Subtract the 3x. We get negative 2y is less than or equal to negative 3x plus 6. Then divide by negative 2. We get y is greater than or equal to 3/2 x minus 3. Notice how the arrow switched when dividing by a negative. Now let's redo the second equation. Subtract the 2x. We get 3y is greater than or equal to negative 2x plus 6. Then divide by 3. We get y is greater than or equal to negative 2/3 x plus 2. We're going to graph this one, and we're going to graph this one. So we need a grid. 1, 2, 3. Here's the negative 3, right there, right? This is the y-intercept. Okay, now the slope is 3/2, so up 3 over 2. This has that little line, so it's solid. The greater than arrow means to be above that. So remember that. Don't do the shading yet. Do the shading later, but you're going to stay above that line later on when you shade. Okay, now let's go to this one. The y-intercept is positive 2. The slope is down 2 over 3. And it is a solid line. This is a greater than symbol. We want to be above the red line. Do you remember where we needed to be for the purple line? Greater than, above the purple and above the red. That's this region of space. Next, find the indicated products and quotients. So this is where we were learning our exponent rules. When you multiply variables, you keep the variable and add the exponents. Number 11, when you divide variables, you keep the variable and subtract the exponents. Number 19, when you have things in parentheses with an exponent, you distribute the exponent. So you have 2 to the third power, r to the third power. That's better known as 8r to the third power. Next one, when you have a fraction to a power, you take the numerator to the power and the denominator to the power. This is a squared over 9. Next, do the products and quotients. So this time we're just adding more numbers in there to make the problems harder. Do your regular coefficients first. 3 times 8, that's 24. Then follow your variable rules. Write the variable and add the exponents. Number 3, negative 5 times negative 3 is positive 15. Now follow the variable rules. A squared times a to the 1 is a to the 3. B to the 1 times b squared is b to the 3. This one's a dividing problem, so start with your normal coefficients. 64 divided by 4 is 16. Now do your variables. A cubed divided by a to the 1 makes a to the 2 when you subtract exponents. B to the 2 divided by b to the 2 cancels away when you subtract exponents. Number 15, 28 divided by negative 7 makes negative 4. M to the 1 divided by m to the 3 makes m to the negative 2 when you subtract exponents. A 1 take away a 3 is a negative 2 exponent. Now the letter p. P to the 2 divided by p to the 1 makes p to the 1 when you subtract exponents. We learned not to leave negative exponents in our answers, so when you rewrite it, the m to the 2 goes in the bottom. Number 13, this is where we were learning FOIL. First, outer, inner, last. So x times x is x squared. Then the outer, x times 3 is 3x. Then the inner, 1 times x is 1x. And then the last, 1 times 3 is 3. Combine together those two x terms. We have x squared plus 4x plus 3. Next one is FOIL as well, but it's even a special case of FOIL because those match each other and you got a plus and a minus. This time you'll only do the F and the L to save time. X times x is x squared. 5 times negative 5 is negative 25. Next one is FOIL. 3a times 2a is 6a squared. Now the outer product, that's 15a. Now the inner product, negative 14a. And now last, negative 35. Combine together the a terms. Answer is 6a squared plus a minus 35. Next, write the following products as a polynomial in simple form. That's the same thing we're just doing. We want to write it as a polynomial. That means to do FOIL, to get a final polynomial answer. So x squared times x squared is x to the 4th. Now the outer product makes plus 1 x squared. Now the inner, plus 3 x squared. And now the last, 3 times 1 makes 3. Combine together the x squared terms. The final polynomial is x to the 4 plus 4x squared plus 3. Here we have a binomial and we're squaring it. You can do FOIL. You can write z to the 3 minus 3 times another z to the 3 minus 3 and then find the answer using FOIL. Or you can use the shortcut version. Square the first term, that's z to the 6. Then double the product of the terms. The product is negative 3z cubed. When you double that, you get negative 6z cubed. And then square the negative 3. Here's the final answer. This is the same thing you get if you did FOIL. Check it out up here. Z cubed times z cubed is z to the 6. Then your outer product is negative 3z cubed. The inner product is negative 3z cubed. And last is negative 3 times negative 3 makes positive 9. Look what you get when you combine those together. You get the negative 6z cubed. Number 13, this goes to the 3rd power. So to do this, we have to use FOIL a few times. First, let's figure out what 2a plus 3b times 2a plus 3b makes. By timesing these together, that would do 2 of them. So 2a times 2a is 4a squared. Then the outer product. 2a times 3b is 6ab. Now the inner product, that's another 6ab. And then last, 9b squared. We can combine our two middle terms together. This answer was the result of multiplying 2 of the binomials together. Remember, our exponent was to have 3 of them. So let's take another 2a plus 3b and multiply it to the trinomial that we just figured out. To do this, we're going to use the distributive property twice. Start with the 2a and times it to all of the things in the trinomial. 2a times 4a squared is 8a cubed. 2a times 12ab is 24a squared b. 2a times 9b squared is 18ab squared. Then go to the 3b and distribute it to the 3 things in the trinomial. 3b times 4a squared is 12a squared b. 3b times 12ab is 36ab squared. And 3b times 9b squared is 27b cubed. Next step is to look for combining like terms. We have 8a cubed. Then we have an a squared b, and later on another a squared b. So when you combine, that's 36a squared b. Then we have an ab squared, and later on another ab squared. So 18 plus 36 makes 54 ab squared. And our last term is 27b cubed. So this long polynomial is the result of that question. Next one, factor over the set of primes. This is called prime factoring. The systematic approach is to divide it by 2 as many times as you can. So 128 is 2 times 64. The 64 is 2 times 32. The 32 is 2 times 16. The 16 is 2 times 8. The 8 is 2 times 4. And the 4 is 2 times 2. Let's find all the prime numbers. 2, 2, another 2, another 2, another 2, another 2, and another 2. This is 2 to the 7th power. Sometimes when you prime factor, you use other prime numbers that aren't 2. It's just that 128 used only 2's to create it. Number 9, we're going to find the GCF and then the LCM. So GCF, what is the largest factor of both? The largest number that divides into both of these? It's 25. Now LCM, what is the lowest multiple of both? Well, the first multiple of any number is itself. So the very first one you even think of is 125, but 125 is not a multiple of 75. 125 times 2 is 250. So 250 is a multiple of 125. Is 250 also a multiple of 75? It's not, because to make 75 turn into 250, you'd have to multiply by a decimal, not a whole number. The next multiple of 125 is 375. Is 375 a multiple of 75? And it is, because 75 times 5 is 375. So the lowest multiple we could think of was 375. Number 13, same idea. First we want GCF, and then we want LCM. So our greatest factor, the largest number that divides into 2 and 10, that's 2. The largest amount of x's that you can divide into both of them is a single x, because that's as many as the last one has. The largest amount of y's that divide into both of them is a single y, because that's as many y's as the first one has. You can't divide more y's into the first one than what's there. Okay, now the LCM, the least common multiple. Remember, the first number you even consider is the number itself, 10. Is 10 a multiple of 2? Yes, it is, because 2 can change into 10 if you times by 5. So we have 10. Now the letter x, x squared. Now the letter y, y cubed. Next, factoring. So we're now to the section about factoring. The first type you even consider is called greatest common factor. You look for that before looking for special patterns. The next step is the patterns. So is there a number that divides into both terms? There is. It's a 2. So we get 2 times x squared minus 9. Now look at the x squared minus 9. Is that a special pattern? It is. It's called a difference of squares. So it factors with 2 sets of parentheses. X times x is your x squared, and positive 3 times negative 3 is the negative 9. So here is factored form. Next one, the first thing you look for is GCF. Is there something that goes into here and into here? And there is. They both divide by x. So we get x squared minus 4. Now, is that a special pattern? Yes, it is. Just like x squared minus 9. That's called a difference of squares. It makes two sets of parentheses. X times x and positive 2 times negative 2. Number 5, is there a GCF? Nope, there's nothing that divides into this and into this. Now look for a pattern. Well, this is that same difference of squares pattern. A to the 4th is a perfect square, and 16 is one of the perfect squares. So two sets of parentheses. A squared times a squared is the a to the 4th. Positive 4 times negative 4 is the 16. Is a squared plus 4 a special pattern? No, it's not. The only pattern we learned about that had two terms was a difference of squares, not a sum of squares. But this one over here is a special pattern. This is a difference of squares. So in the next step, we have a squared plus 4, but then the a squared minus 4 will make the two sets of parentheses. A plus 2, a minus 2. Next one, look for GCF. Anything that they all divide by? Yeah, they all divide by 5. So we have 5 times a squared, and then minus 6a, and then plus 9. Now look in here. This is a trinomial. Is it a special pattern? It is. It's called a perfect square trinomial. One set of the parentheses squared. The square root of a squared is a, the square root of 9 is 3, and the middle term has a minus sign. Next one, number 9. Because the leading coefficient is negative, you automatically start by factoring out a GCF of negative 1. Then you look in the parentheses to see if it's a special pattern. And it is. It is a perfect square trinomial, just like number 7 was. So the square root of k squared is k. The square root of 324 is 18. And, whoops, sorry about that plus sign, is 18. And because the middle term is negative, you put a negative. Number 12, this one's different than the last ones because it has 4 terms. So the technique we learned when there were 4 terms was to try grouping. Let's rearrange it so that the terms go in this order. Then we can find a GCF in the first 2 terms. You see how there's an x in both of them? So we get x times 2a plus 1. Then we can look for a GCF here. See how they both divide by 3? So we can write 3 times 2a plus 1. Now observe that both of them have a 2a plus 1. So we can write the 2a plus 1 down, and then in another set of parentheses, use this and use this. Next one, they all divide by 2. Is this trinomial a perfect square trinomial? It is. The square root of x squared is x. The square root of 256 is 16. And because the middle term is negative, this is negative. You might be wondering how I know that it's a perfect square trinomial. What I'm looking for is the constant term one of the perfect square numbers? Is 256 a perfect square? It is. I know that 256 is 16 squared. Then I'm looking to see if the middle term is twice the square root of this. The square root of 256 is 16. I'm looking to see if 32 is twice 16, and it is. Okay, number 18 is a special pattern. This is called a difference of cubes. So the parenthesis pattern was a binomial, but then a trinomial. In the binomial, it's r minus s. Then you create the trinomial from these pieces. Square the r, change the minus into a plus, and take the product of the two things. That's rs. Then square the s. Number 20, this is another special pattern. This one's called a sum of cubes. So binomial, then trinomial. The cube root of this is 2x. Then put a plus sign to match this, and then the cube root of 1 makes 1. Now let's create the trinomial using this. When you square the 2x, you get 4x squared. Switch to a minus sign, and take the product of those two things. Then square the 1. Next one, we're asked to factor. This is a trinomial. There's not a GCF, so we're going to factor using FOIL. X times x is x squared, and positive 5 times positive 1 makes 5. And 5 plus 1 adds to 6. Number 2, there's no GCF. It's not a special pattern, so let's try FOIL. X times x is x squared. Negative 3 times negative 1 is positive 3. And negative 3 plus negative 1 adds up to negative 4. Number 3, let's try FOIL. N times n is n squared. Positive 3 times positive 2 makes positive 6. And 3 and 2 add up to 5. Next one with FOIL. N times n is n squared. And to make 24, we have some possibilities. Like it could be 1 times 24, 2 times 12, could be 3 times 8, 4 times 6, and so on. Because I want this to be negative 11, let's use negative 8 and negative 3. Okay, more factoring. Again, these are trinomials. Let's consider using FOIL. Y times y is the y squared, and then negative 6 times positive 5 makes negative 30. Negative 6 plus 5 adds up to negative 1. Number 9, let's use FOIL. T times t is t squared, and then we need two numbers that multiply to negative 80, and we want them to combine to 2. Let's use positive 10 times negative 8. Because these times up to negative 80, and they add together to make positive 2. Okay, number 10, let's use FOIL. We have t times t, and then we need two numbers that multiply to negative 72, and then two numbers we choose have got to combine up to negative 14. So we're not going to go with 8 times 9, because even though that makes 72, I can't get my negative 14. We could experiment with more numbers, but what's going to end up working is 18 times 4 is 72. So let's use minus 18 and positive 4. Number 27, they all divide by 2. So there is a GCF. And I also noticed that there's a letter A in all of them. So the GCF not only has a 2, but it also has an A squared. This leaves A squared plus 5A minus 36. Now factor the trinomial part using FOIL. A times A, and now we need two numbers that multiply to negative 36, and the numbers combine to make a 5. Well, there's different choices, right, that make 36, like 12 times 3, but with 12 and 3 you can't get a 5. Or 18 times 2, that's 36, but that doesn't make a 5. Or 9 times 4. Well, with a 9 and a 4, you can get a 5. So let's use positive 9 and negative 4. Next one, we're doing GCF and LCM again, but this time we have polynomials. We need to have factored form. So the first one factors as 2 times t plus 3. This other one is already factored. It's just t plus 3. Now let's get our GCF and our LCM. What divides into both of them? They both have a t plus 3. That's our common factor. Now for LCM, we need 2 times t plus 3. That is what the first one already is, and the second one can turn into that if you times by 2. Okay, number 3, let's factor the first one. S plus 5 times S minus 5. And then factor the other one, 2 times S plus 5. Now let's get our GCF and our LCM. What's common to both? Hey, it looks like they both have S plus 5. That's your common factor. Now let's get a multiple. We have to have a 2 in it because this one has a 2. And we have to have S plus 5. They both have that. And we have to have S minus 5. Next, determine the solution set of the equation over the real numbers. That simply means solve the equation. The fastest way to solve this one is to factor it. X minus 3 times x minus 1 equals 0. Because negative 3 times negative 1 is positive 3, and they add up to negative 4. In the first set of parentheses, x equals 3, and the other answer is x equals 1. It says check your answer, so you could plug them in and make sure they work. Number 4, let's try factoring again. We have r times r, and now we need two numbers that multiply to negative 54, and the two numbers we use have got to make positive 3. So how about positive 9 times negative 6? In the first one, we'll get r equals negative 9, and in the second one, we'll get r equals positive 6. Number 6, let's use factoring again. We have x times x plus 4. So our first answer gets us x equals 0, and in the other factor, we get x equals negative 4. Next one, we're asked to graph the solution set of the inequalities. This factors as t times t minus 4. If we have two factors that multiply together and the result is less than 0, we have some cases to consider, some possibilities. Case number 1 for multiplying two things and getting an answer less than 0. The first one might be less than 0, and the other one might be greater than 0. If the first one's negative, but the other one's positive, their product would be less than 0. The other case to consider is that the first one might be greater than 0, and the second number might be less than 0. Let's solve these. This one right here is already good, but over here we could get t is greater than 4. So this statement says t is less than 0 and t is greater than 4. Yeah, that's not possible. That's empty set. Now this one right here, let's add 4 to both sides and get t is less than 4. Okay, here's what it says. T is greater than 0 and t is less than 4. That's telling us that t comes between 0 and 4. We can graph that. Here's 0, here's 4. We have open endpoint dots, and the shading comes in between. Next is where we were learning division. We started by dividing polynomials by monomials. The technique is to divide each term by that denominator. So 25 divided by 5 is 5. X cubed divided by x to the 1 makes x squared. Now go to the middle term and divide. 15 divided by 5 makes 3, and x squared divided by x to the 1 makes x. Now go to the last term and divide. We get negative 6, because the x's cancel. Number 3 is the same thing. Divide each term by the denominator. So 16 divided by negative 8 is negative 2. X cubed divided by x to the 1 makes x squared. and a y on top and a y on the bottom cancel away. Now go to the middle. Negative divided by negative makes a plus sign. 24 divided by 8 makes 3. X squared divided by x to the 1 makes x. And y squared divided by y to the 1 makes y. Now go to the last term and divide. We get positive 8. The x's cancel, and then we get y squared. Okay, number 9. We're no longer dividing by a monomial. This is where we learned about long division. So we're going to take x plus 3 and divide it into x squared plus 15x plus 36. X times x makes x squared. I'm always trying to make something here that is identical to what's right up above. And then x times 3 makes 3x. Now subtract. We get 12x. And bring down the next number. Then x times positive 12 makes 12x. And 12 times 3 is 36. The remainder is 0, so we're done. Here's the answer up above the bracket. Number 15, same thing. We're going to use long division. We're going to take 2n plus 3 and divide it into the polynomial that's in the top. 6n cubed plus 5n squared plus 0n plus 9. Recall that you have to have a placeholder if you're missing any of the terms. Now let's divide. 2n times 3n squared is 6n cubed. 3n squared times 3 makes 9n squared. Now subtract. 5 take away 9, that's negative 4n squared. And bring down the next term. 2n times negative 2n is negative 4n squared. And negative 2n times to the 3 is negative 6n. Now subtract. 0 take away negative 6 makes positive 6n. And bring down that next number. 2n times 3 makes 6n. And 3 times 3 makes 9. And you get a remainder of 0, so you're all done. Here's the answer above the bracket. Next one, use the factor theorem. So the factor theorem was a fast way to see if this binomial divides evenly into that without using long division. To use the factor theorem, you're going to figure out what is the answer for x that you minus 7 from and get 0. Like, what number minus 7 makes 0? That would be 7. Take that 7 and substitute it into the equation that you're given. And see what the answer is. This is 49 take away 35, which is 14, and 14 plus 14 is 28. If this made 0, then that's a factor. If this doesn't end up to be 0, then that is not a factor. So the answer is no. Okay, number 5. We don't want to use long division to divide this into this. That'd take a long time. So the faster way is with the factor theorem. First of all, what value of x makes that turn out to be 0? That would be negative 3, because negative 3 plus 3 is how you get 0. So let's fill in negative 3 into this thing and see if it really does make 0. So we have negative 3 to the 4th power minus 3 times negative 3 to the 3rd power plus 9 times negative 3 and then minus 27. We want to know what that makes. Certainly a calculator would be good here. Well, I typed it in, and assuming I typed it in correctly, I got 108. So since this is not 0, then negative 3 does not work.